Hey guys, welcome to this new tutorial in Grasshopper. This will be Kangaroo tutorial 2. So we're gonna be looking a little bit of how to work with the data paths, like in trees, and how to flip matrices around in order to deal with the surface, right? So I'm gonna just start by creating some sort of curve here in the front view. Uh, Anything you want, really. And I'm gonna go here in the top and just copy that, so I have two curves like that, right? Something that we could work with. Um, and now I'm gonna just bring this into Grasshopper with curve. Copy this command, set one curve, and then set one curve there, right? So we're gonna start with the loft. Simple operation, right? Connecting these two curves together, and that's all good. And we're also gonna just create a divide surface, right? Because we want to get points, right? So I'm gonna just plug this surface here, and you see that automatically I get a grid of points. So that's good. We could add a slider here. If we say value from maybe 0 to 30, and then type integers, we could connect that to both x and y to see that we could just kind of work with more or less. So that's good. Let's keep that in mind. I mean, we could do two sliders if you want, just to have a control over the u and the v separately, right? So maybe you want more in this direction and less in this one. That's up to you. So let's do some lines in between these guys. So I'm gonna do, because I'm gonna do a shift list, right? To just shift the points one point to the side. So every point will just be shifted in this direction, right? Like, or basically the list, you'll get the next one in the list, because the shift automatically kind of shifts the list by one, so we don't have to put a slider there. And basically the problem in this operation is that you want to work when you're doing the line now. If you do the line between the point and the shift, you'll get the line, but if you check the last one of that list, has a 0, right? Because you have shifted the list to the side, and so there's 2 points that are in the same position, and then it's creating a line with 0. So before, Grasshopper used to have something here that is called a short list. Now it's actually, you have to just bring it in here like this, just to be more explicit about the whole operation. So I'm gonna wire that up, and you see that now I should not have the member that it's 0, right? So we are avoiding the element that doesn't really have a match in, so we're keeping that out of the, so this is good. We have the lines in one direction, but I'm also looking for the lines in a different direction, right? And maybe you think, well, I understand that this element, it's connected to the next one in the list here, right? But now I'm going to connect this guy, this element that is the first element in the list in this bunch that is going, let's say, in the u direction, with the first element in the second. Let's say if this were columns and rows, I want to connect it with this guy now, right? So there's a very easy way to do that. You just do a flip matrix. What would do that is actually just, we could look at it, but it's gonna do now that you have, in this case, you've seen that we did 6 U's and 20 V's. Now we have basically the other way around. We have 6 or 7 in this case V's and 20 U's, right? So we have flipped the logic of this matrix now. It's almost like transferring like columns for rows, right? You see that now, before we had so many elements in so many lists, and now we have the inverse relation, right? So that's useful because actually we can do the shift operation again, and now it's going to be in this direction, right? So if we repeat this idea of the short list, we could actually create the lines in the different direction like that, right? So that's pretty useful. And again, we are avoiding the last one through this short list, right? So we have the lines in both directions, so that's pretty good. So let's go to kangaroo and start bringing some of the elements. So we want to do a simulation of kangaroo. For that, we need a timer. I'm going to change the interval of the timer to 20 milliseconds. I'm going to connect that, but I'm going to turn it off by double clicking on it. So I'm going to also bring a toggle switch, and I'm going to connect that there, leaving it in true, so it's resetting the simulation. So these lines were going to be springs, right? So let's bring springs from lines, and I'm going to connect that there, and with shift connect this other spring. So let's start making some space for us to work. So the lines are going to be the springs for the system, right? And we want to just flatten whatever we're bringing in here. So that seems to be working, right? If we just run it now, we don't have any anchors or any force. We need to add some anchor points and some force. So let's try to do that. So let's, the anchor points are going to be, let's start with the anchor points of the elements in one side. So I'm going to just type item. So list item. If I put this point, so if this side, these guys are going to become the anchor points, and these guys I also want to flatten them just in case. So, and maybe let's put some gravity, so unary force in every point, right? So that's every point, and the force is going to be again in set. Oops. And a slider of values minus 1,000 to 1,000. Right, so pretty straightforward here. And so we have our force, and we shift click to add that to the forces of kangaroo, right? So that's looking pretty good. So we have a force in this case going up. These are springs. Let's see what we're getting right now. So you see that we got something going on, and the force is going up, but we can make the force go down. And you see that the springs are way too strong, so they kind of tighten the geometry like that. So that's fine. Let's add some more constraints, right? So the anchor points right now we're having one side. Let's add the other side. So I'm gonna get the item. By default, the I is 0, right? That's why it's getting these guys here. But if I get it from a flip list, I can get it from this side as well, right? So I can get all this row to be an anchor point, and I'm going to shift add those to the list of anchor points. Now I want to think of just the other two edges. So for that, I'm going to just basically reverse the list. So the list of points that I had, I reverse it, and I get the item as well. So that's kind of the opposite end, and I add that to anchor points, and then I'm gonna reverse the flipped list, so I get the other side. So I get this edge, the top one, and the one on the left, right? So I'm gonna just shift connect this one here as well. So I have, let's try it now, and you see that we're getting something there. Let's try it. So we're kind of playing with the force a little bit. So we're kind of deforming it. Gravity would be something like negative, right? Like that. So, but maybe we want to see the geometry, right? So let's again turn this off for a second. And what are we're gonna plug something in geometry here. We could just plug the lines. These are the lines, and now if we put line, or basic, sorry, curve. In this side, geometry out, we could start getting that. So that looks pretty like much better. We could actually get rid of some of the elements like by turning out the preview of them. We could just basically start seeing more the loft, right? So that's pretty interesting. It's kind of, you see, useful would be to create a slider for the rest length, right? And we could just basically add the values to basically start manipulating how this works. And you could start getting some interesting effects there. Actually, I think this value should be from 0 to 1. I'm not sure. But anyway, no, it should be fine. You see that when we're just getting too much, the spring starts kind of wrinkling, which is, I think, kind of interesting. I'm not a big fan of minimal surfaces, so it's just the way things work here. But then you could also just make this slider of gravity be 5,000, for instance, just to start pushing this a bit stronger, right? It's up to you. Just you can play there. But let's look at how to actually how to not only create these curves, but let's create a surface. So I'm gonna remove these lines, and I'm gonna just add a surface from points, right? So surface from points needs to understand how many elements in the U direction you have. So our U is this one. But as much as this U needs to be kind of altered. I mean, initially I kind of thought, well, if we just plug the number of U parameters here, right, that element there, that should be it, and these are the points, right? So that should make sense, but it doesn't somehow. So I realized that you have to just use a subtraction. It's an addition or a subtraction, I'm not sure. We're gonna check. Of 1. I'm gonna put 1. And so whatever the value is, -1, or maybe it's an addition. Let's try addition. Yeah, that's the one, right? So we don't need to plug these points because these points are now going into the geometry. I'm going to replace the lines now for the points, and out of the geometry I'm going to get these points, right? So this is going to be the deformed surface now. So if I turn on my simulation, you see that it's not working really. There's some mistake here. Let's check it. Oh, let's flatten the points. There we go. And that's it. So the result now, it should be the surface, and as much as the visualization of Grasshopper should be kind of this a bit polygonal for resolution, the result we should be getting, it's perfectly smooth, right? Because that kind of surface should be completely smooth. So you can do pretty interesting stuff with this, and obviously these initial curves are completely interactive still, right? And you're just working with the and real-time simulations of that kind of gravity and relaxation in a way algorithm, right? So it looks pretty interesting. We could bake that guy out just by right-clicking and middle mouse clicking that, and then turning off the simulation. So this surface has been generated through this technique, just kind of calculating the gravity and like making these kind of edges control points. So you could just conform it to any surface. You could eventually like add more control points or anchor points in the geometry whenever you want. So you could be just start adding moments in which this actually doesn't fall with gravity all the time, but maybe some of these points. We could do that just like to add a little bit of extra to this tutorial. Let's add some random element, right? So let's say item, list item, sorry. So I'm gonna copy this, but instead of saying you see that what I'm getting from this operation is a series of points, right? So I'm gonna just flatten the result. So I'm gonna get item not 0, but let's get item 3. You could do it a slider, right? Item 3, and then from that list I want item 3 again. So just to get that point, right? Just because we got the list, first the row and then the point in that list, so we could just add this guy with shift to anchor points and then saying true, and we should get 1 point. The thing is that obviously just because this surface is it's interpolating between like all these other points, it's not enough to just modify the surface so much, right? So you see here that only one of those points, the control points of the surface, are really being affected by this point we decided to kind of grab. So yeah, that's the way it happens here. We could just add a whole row or a full kind of column with this technique, just like selecting additional ones, right? I actually like better the result without that. So let's get rid of that and then maybe add an experiment of how it works with the, you see that we're leaving this row as anchor now, so we probably would want to just create a bit of extra gravity and then maybe bake this guy to see what we're getting. And you see that we have this kind of situation like this. The problem obviously that as much as these points are kind of anchor points, the surface technique that we're using, it's not should actually reach here and then start again, but because we're this kind of network surface or grid surface uses these points as control points, only the edges are going to be considered as kind of, you know, like sharp edges like that. These are just control points, so they live outside the surface. So I mean, you might like the effect, you might not. It's up to you to design it. So I think that's gonna be it for now. I hope that some of these elements here, the flip list and the idea of how to just navigate the neighbors in a list that already has that's in the second branch of the list. So you have a list in this direction and this direction. How to work with this kind of U and V parameters, it's helpful, and also like how to work with these kind of spring conditions and kangaroo for surfaces. So yeah, that's it guys, see you soon.